Once the water cycles through the container and you can see it collecting in the bottom of the plastic tray, it's time to pour it into another container in order for us to measure it. If there's fertilizer prills or substrate particles or some dirt in the bottom, you can filter it through a paper towel. But if you're just careful, you can just pour it into the container without that detritus getting into the container. Of course, I actually have some substrate and fertilizer that got into the container when I was pouring it out, so I'm just going to put my finger in there and pull it out, get rid of it. Again, like I said, it's nothing fancy. We're looking for big differences here in the measurements of pH and EC. If we're looking for fine measurements that can only be found in a research setting, then that's not really going to happen out here in the field. We're trying to find big problems between whether or not the plant was fertilized or whether or not the fertilizer is still available in the production cycle of the plant. Then you can either measure the EC and the pH of the plant in this container or pour it into another container that's a little bit smaller. I have chosen to pour it into another container that is smaller, and this is the EC and the pH of the plant that is chlorotic or it is has poor health. The pH of the leachate that came through the bottom of the container is 6.7, and the electrical conductivity is 0.22 millisiemens per centimeter. On average, when the plants are in the growing season, and this is midsummer here at this nursery, the electrical conductivity should be between 0.5 and 2, preferably somewhere around 1.2 if the fertilizer is releasing and the plant should be growing. Here we see that it's 0.22 or 0.23, which tells me that there's no nutrients available in this container for the plant to grow, which is why it's probably chlorotic. That reminds me, it's always good to measure the pH and the EC of the irrigation water that you're using for the pour through, and also the irrigation water that you're using to irrigate the plants daily. The sample we collected from the chlorotic plant was pH 6.7 with an EC of 0.22, and the irrigation water we used to conduct that pour through has a pH of 6.4 and an EC of 0.07. So if we subtract that from the 0.22, that gets to be 0.15 EC, which is the only nutrients that are being delivered from the fertilizer in the plant. So we can safely say that the plant's perhaps missed being fertilized this spring, or the plant could be held over from last year and the nutrients that were applied are gone by now. I'm now going to measure the pH and EC of the leachate from the comparatively healthy sample here on your right. The pH of this sample is 5.8, and the EC is 1.0, which means that there are nutrients available for the plant to grow. And usually when nutrients are released from the fertilizer prills, as you can see on top of the container, that will lower the pH of the leachate. So we can see that this plant is in the prime of production. Fertilizer is releasing, thus plants are green and it's healthy. This one needs to be top dressed with fertilizer. And if we look at the top of the container here, we can tell that it probably was missed this spring by accident and just needs another dose of fertilizer. In summary, conducting a pour through on healthy plants and unhealthy plants gives us at least some data in the field that we can use to determine what went wrong and provide some information that we can use to intervene and try to improve the health of the plant. For example, on this plant, it was chlorotic, and we found out that it probably missed getting fertilized in the spring earlier this year. Now there are some other ailments to it. You can see a couple of brown spots here on the foliage and a brown patch here on the back that we may think is some sort of fungus or maybe a pest, and spray pesticides or fungicides on the plant trying to cure this particular problem, when in fact it just needs to be fertilized and it will probably grow out of these symptoms. And we will have saved time and money by not spraying and not applying herbicides or pesticides when we don't need to. Lastly, conducting a pour through is not a one-time thing. It needs to be a regular procedure that is integrated into production. Conducting pour throughs bi-weekly or monthly through the season will give us a good information on the fertilizer that we're using, when it is released in production, when it is most available, and when it's running out, based on our nursery production system with our substrate, our containers, the way that we water, and the source water quality that we're using. So begin conducting pour throughs, but remember, it is a marathon, not a race. We have to do this over a long period of time to get a good picture of what healthy plants are supposed to be reading, and then so we can determine what is going on with our unhealthy plants.